Hello everyone, this is part 4 in our series on Typst. Last time we talked about paragraph adjustments, spacing, some document metadata information as well. This time we will focus on a couple of things that are more directly connected to linguistics, starting out with code blocks. Then I'll finally talk about packages, because up until this point we haven't really loaded any packages, which is kind of amazing if you come from LaTeX, the amount of stuff that we managed to do without any packages. So everything so far has been out of the box. And particularly we'll talk about syntax trees and numbered examples. So I'll give you just very quick examples of how to load packages that can do that for you, because next time, in the next video, I will specifically talk about phonology and my own package that I've been developing for this reason, to kind of facilitate your life as a linguist, especially if you work with phonology. So we'll start out with code blocks. Now, if you've already used Markdown or Quarto, if you use R or even Python, Jupyter Notebooks, you're probably familiar with the backticks for code blocks. So let me just create here a new section called code blocks. And I'll just insert some text here. So to create a code block, we simply use 3 backticks or grave accents. So that would be something like this. 3 backticks, and we close it with another trio. So 3 backticks to open the environment, 3 backticks to close it, and then everything we write inside will be in the typical monospaced font. There are many defaults here. Well, we'll first create a very simple code block, and then we will change the formatting a little bit by going back to the preamble and customizing a code block for us. All right, so let's just do some Python code block here. So I'll just write Python over here to specify which language we'll be using, and I'll write print something like hello world. Okay, so you can see there already in our document that it's rendered. You do have a code block. It's not an object yet because we haven't wrapped it with the figure function. So we can just go ahead and do that. So let's just do figure. So let's do figure here, and then go back here, add some caption. Let's just do something like a code block or a complex Python code block. All right, so now we have a figure, meaning we can refer to it. And you can already tell that, just like before when we did tables, the function figure detects exactly the type of object that you have inside. So in this particular case, it detects it's a code block. And by default, it will use the word listing as the numbering label for that. So we could even create now a tag here, something like code block, I don't know, Python. So we can refer to it when we are writing a text. So we could do C code block Python, etc. And you can see here we automatically get C listing 1. This is listing 1, a complex Python code block. All right. So this is the basic stuff, right? So as usual, every time you want to refer to something, you want to create an element of like a float that can be referred to, you can wrap whatever it is that you're doing with the figure function, and that function will detect the object that you have. But the nice thing about the figure function is that you can actually customize a lot inside the function. So for example, I'm not a fan of the listing label, so I just want to add the supplement argument here, and instead of using listing, I'll just do code block. So now you have code block over there, and you can even do kind code. So, you know, if you do table of contents later on, this will create a new kind of object or element in your document that can be easily referred to later on. All right, so we have our code block. We can refer to it. It has a tag. It's correctly labeled as code block, custom labeling. So that's all good, but it is a little bland. So it is completely white. We should probably add some background. So what we'll do is we'll come back here under the comment for code blocks. We'll set it up in a way that looks a little more like a code block. So we will adjust the rendering. So for that, we'll again use the function show, because we're changing the aesthetics of an element. And for anything that's related to code, you will see the word raw being used. So raw basically means code for our purposes here. So raw text, etc. And we can append this keyword where, and here we can say, okay, every time we have a code block, meaning every time it's a block, we're going to do something to it. We're going to do some functional programming. This kind of is similar to lambda calculus in Python. You know, some functions in tidyverse, if you use R, also do this. So we'll just create a variable, which is it. We'll do the assignment operation here, which is equal and greater than. And then after that, we'll open a block of code where we will specify exactly what we want that to be. So inside block, we'll add some content, and then we can decide what we want to fill or what the background of the code block will be, as well as the inset, the radius, the width, etc., etc. So we can just do fill. If we do gray, for example, you don't see anything right now because we have to actually print the it. Now, it here is just the variable, right? So take the element itself, make some changes, and then print it, right? It doesn't matter what the word is. You could use whatever variable you want, but it seems to be pretty common to do it in Typst. So if you did, I don't know, if you did X here, you could do X over here as well. Okay. But you'll notice that people have a tendency to use it for Typst. So it's okay. It's working out, but it's still a bit odd because first it's too dark. So we probably want to lighten it. So we could use the function lighten. We could append it to the color, or we could just use luma, which is a nice function that gives you a range or a continuum going from 0 to 255, right? So if you do 240 or 220, you can see it gives you kind of a range of shades of gray. After that, you can change the inset. I don't know, 10 pt will already give you something that looks a little more like a code block. The radius will adjust the corners. So if you do, I don't know, 5 pt, you will notice that it's rounded now, which looks kind of nice. And finally, you could also do width, and you could just automatically adjust the width, which is kind of what we have right now. You could also do 10 centimeters, whatever you want. So you can customize the width of the code blocks, in which case they will always be 10 centimeters wide, unless, of course, you add conditionals to it, or you can just do auto, which makes perfect sense because then it will auto adjust the width of each code block. And of course, you can change here to 240, which is a little lighter. All right, so this is a typical code block. It looks like a code block, looks nice, and you can see it only required some minor adjustments. The important thing here is to kind of understand the logic. So we're doing show because we're talking about the rendering of a particular element, and then after that, we're running a function here, which is taking an element and then adjusting a block and printing the element later on. So this, of course, only applies to raw, meaning only when we run code or write code, etc. And you can see the syntax highlighting is also working out of the box, which is great. All right, so this gives us a code block, but now I also want to add syntax trees and numbered examples. So I'll just add one more section here called syntax trees and another one called numbered examples. Now this will finally require loading a package. And for that, we're gonna visit Typst universe. So you can see the URL right here, typst.app/universe. Right now, as of December 2025, you have about 1,000 packages and templates here. So you can kind of browse and take a look at what you can download from their website. You have CVs, slide presentations, posters, etc. For our purposes, we'll start out with a package called Arborly, which is really nice. It's a library for syntax trees. You can already see examples here. So it looks quite similar to what you would do with TextQtree in LaTeX if you've used that. Now, it's very easy to import a package. I will just copy this line here and paste it at the top of the document right here. I mean, that's just convention. And then I will copy the example and paste it inside our current document. I mean, before you do that, you probably want to create a figure so you can refer to it. So let's just do figure again. Let's do caption and write a syntax tree here. And then finally, you can just add the code without the hashtag. All right, so this gives us a figure. We have syntax tree is the caption. Of course, you could, in theory, if you're doing a lot of syntax trees, you could add a supplement here where you just do something like syntax tree as the label, right? In which case you would change the caption probably. So a simple example. So you can very easily create a new object class for syntax trees alone, right? Which is kind of nice if you're doing a thesis or a book that will have many trees and you don't want to call a syntax tree figure because you use figure for something else, like for a more typical figure. All right, so this is how you import a package and use it. So you can see it's very straightforward. You can just use the import function at the top of the document. You will notice at the end of the line here, you have colon, and after that you have tree, meaning we're literally saying, take this package and from this package, import only the function tree. So you could use an asterisk to import everything. If you used Python, you're already used to doing that. But in this particular example from their package, we're only importing this one particular function. You can, of course, visit their repository and check out all the functions that they have in the package. All right, so the next thing we'll do is we'll take a look at this other package called eggs, which is for linguistic examples with a very minimal syntax. And again, here's a set of lines you have to copy, right? So let's just copy that and paste it over here. And we'll copy the example that they give, and which you can see rendered over here. And I'll just paste that inside our numbered examples section. There you go. So you can see here that we have everything you would expect if you need to to add examples to your document with glosses, and if you want to number them and refer back to them, you can see the label is right here. So you can, again, just refer to it in your text. And this is the syntax that you have to use, right? So you have the third line and fourth lines here. One example is with gloss, one is without glosses. So you can do both, which is kind of nice. Of course, you have to escape the asterisk because an asterisk in Typst means bold. So you have to escape it, otherwise it will not compile, right? So you can see it's very straightforward to import a package and use the functions in that package. So far, we've seen here syntax trees and numbered examples. The natural next point would be, okay, how do I enter IPA symbols? How do I do all of that? Which is something that I myself, working in phonology, have to do quite often, as you can imagine. There are already some packages for that if you check Typst Universe, but you will notice that the syntax required is a bit clunky compared to TIPA. If you're used to LaTeX, you've already developed some muscle memory related to which symbol you have to use for which phoneme. All right, so this is everything for this video, and next time we will talk about phonology exclusively, and I'll finally be able to introduce a package that I've been developing. See you next time.